Okay, I think we're turned on now. I want to take just a few moments here and talk about our first test, which is coming up on Thursday this week. Let's see, today is, what would we say, 23rd, 24, 25, 26, 27. It looks like the 27th of February. We've only truly covered, and we'll finish going over the homework for the last section on Tuesday. 3 sections. However, they are good sections. They've got us started in the area of proving things and constructing proofs. And so let's talk a little bit about what you should expect to see on the test. There will be, I'd say, about 8 problems, about 8 proofs that I have you construct for me. And we've got 3 sections, so, 2 to 3 out of each one, probably something like that. Section 2.1 was our introduction to proofs. We talked there really about providing direct proofs, where you take your given information and you say, okay, if this stuff happens, then this stuff happens, and then this, and then this, and then this, and then this, and then therefore, boom, the thing you're trying to prove. And those are straightforward. Many times they're a calculation that we have to provide, but usually they're pretty straightforward. We also talked about how certain if-then statements, if we're trying to prove those, we can, sometimes it's easier to, hold on just a second. Excuse me. It's sometimes easier to prove the contrapositive. So we did a few proofs by contrapositive, and very similar to that, we did some proofs by contradiction, where you assume that the opposite thing you're trying to prove is true, and show that if that were the case, something ridiculous would happen. We've used that actually a few times. It's very helpful when we start talking about rational and irrational numbers sometimes. So proofs by contradiction. And then we had also proofs where we're trying to prove that things are if and only true, this, if and only this. So those are kind of biconditional proofs. Where you really do 2 proofs. You say, well, assume this side and prove that one, this side and prove that one, and any one of those could perhaps be a proof by contradiction or something like that. So probably a couple problems out of that section. The math concepts we talked about. In that section varied. There were lots of things that we kind of assumed you probably were already familiar with. But I was looking over the problems. The kind of things that we ended up talking about were things like lines. We talked about the floor function. We certainly talked about polynomials. Even and odd numbers. Rational and irrational. Numbers, and multiples, or equivalent divisibility. So what I would try to do out of that section is probably throw you a couple problems, kind of like we did, but a different, probably probably not repeat anything that we've done, but the same kind of things that we've done there, using those same concepts. Then we also did a section on sets, where we did set proofs, and these were showing that one set is a subset of another, what I call set inclusion proofs. It's where if you want to show this is a subset of this, you take a general element out of this set and show that it has to be in this set. And then we also did equality proofs, which were double set inclusion. You show this a subset of this subset of this. And then we also had, this is another equality proof, but equality to an empty set, or to I guess I should say the empty set. And that was typically a contradiction proof. We would assume that there's something in this set, and then show that by making that assumption, something goes crazy, something that can't happen. We contradict ourselves, and so the set must not have any elements in it. It's an empty set. The concepts here that we dealt with, and maybe it helps if I put a little divider here, and I'll put a little divider here, were the different kind of set things we talked about. We talked about the complement of a set. That's an E. We talked about the union of a set, the intersection of sets, and then also the difference of sets. So probably a couple out of that, just to show that you can do those kind of proofs. Again, those were fairly straightforward kind of proofs. And then the ones that we're finishing up now in 2.2 are the induction proofs. And those include the strong induction proofs. And the difference in those, the induction proofs, we say, all right, well, let's prove this for a beginning point. The first thing that we're going to try to prove this for. It's always a case where we're trying to prove it for an a countable kind of set. Prove this for n, integer n greater than whatever, 0, whatever. And then we prove it for the first one, and we say, well, let's assume that it holds for some integer out here greater than our starting point, greater than or equal to our starting point. Then show that it has to work for the next one. And that's enough. Then you can go back to the first one, say then that gives us the next one, the next one, the next one, the next one, and on and on. The strong induction proofs, again, you do an initial one like this, and you then say, well, assume it works for k and everything less than that. And sometimes if you know that you have to reach back like 2 or 3, you might have to do 2 or 3, whatever it is, here at the beginning. That was an alternate version of the strong induction that I showed you, where you have to do the first whatever, and then you say, okay, let it work for k from this point on, okay, some k at least this or bigger, and then because you reach back 3 or whatever it is, you've got enough here to reach back then and get the rest of them. Okay. The concepts that we dealt with on this one were, again, fairly basic. We did a lot of sums. We dealt with inequalities. So some of the proofs that we dealt with, we proved inequalities for integer n greater than whatever, right? Those are okay. You know, the pro and con on those is that you do have more flexibility when proving that things are something greater than the other one, but sometimes it's less obvious exactly what it is you need to get rid of, right, or to put in or throw out. But again, that's the scratch work side. I'm sorry, you do it over here. The scratch work side of things, you know, along with the test, I'm going to give you some additional paper and just let you just, you know, do that work there, and then when you're done, just pop the whole thing together. I probably won't grade the work. I mean, but not the work, the scratch work. I'll grade what you put on the test. But we've talked about this many times. You know, to write a nice, neat proof, it typically requires a little bit of scratch work off to the side to figure out exactly what you're trying to do, and then you can organize that into a nice, neat proof. And that what I see on the test is what I'll grade. Okay. I was thinking, oh, and we also in the math content, you know, we also dealt with, and these are kind of nice a lot of times in induction proofs, factorials. So, you know, if I pulled maybe, I don't know, 2 or 3 induction proofs, maybe one with the sum, one with the inequality, one strong induction proof, maybe a couple of the set proofs just to show that you can do them, and then maybe 2 or 3 of the things out of 2.1, have you do a proof by contradiction, prove an if and only if statement, maybe prove something using the floor function or even or odds or something. You know, I think that would be a good, that's a long enough test. I think that would demonstrate that you can do what we're asking you to do in this first bit. Okay, what we'll do Tuesday then in class is we will finish up those induction proofs in 2.2 that we still lack. I'll answer any questions you have about this kind of stuff, and then if we have time we can talk about what we're going to do next week after the test. Okay? All right, if you have any questions about this kind of stuff, let me know, and I will see you in class.